If you've ever thought about, like, I love the idea of kids using different strategies, but I also know that students eventually need to learn the algorithm. You are not alone. The real question is not like, should we teach the algorithm? But instead, it's when, it's why, and what do students need to understand before we introduce the algorithm? So in this short video, I'm not going to teach strategies. I just want to show you how I decide when to teach the next strategy when students are solving word problems. So here's what guides kind of all of my work. I believe that problem solving comes before procedures. I believe that students have to use what they know and can do to solve problems before we give them any written ones. And I believe that efficiency should come after we establish understanding, not before. Now, that doesn't mean that algorithms aren't important. They are. But I don't lead with them because without the reasoning underneath that algorithm, then it just becomes steps to memorize instead of the tools that students need to truly understand the math. So when I'm listening to students solve problems, I'm asking, like, what do they know right now? What strategy do they fully understand right now? And I'm really just trying to get, like, what does the student already understand? And what might be the next step for them? Because the progression of learning isn't a checklist. It's a way of building on what students already know and advancing their understanding. So first, I listen for sense making. Can the student understand the situation? Can they tell me what's happening in the problem and what's happening with their strategy? Then I listen for maybe the reasoning that they're not able to articulate. Here's what I mean by that. Like, I'm listening for their mental math reasoning. Are they decomposing numbers? Are they using a known fact? Are they able to explain their thinking fully in words? And before I ever introduce strategies, I'm looking for that flexibility. Can students approach the same problem in more than one way? Can they see the connections between using blocks and using a number line, between using a number line and using incrementing algorithm? And once I start to see that students can make those connections, that's when I start naming the formal or written methods for them. When algorithms come in, they represent the student's thinking that's already taking place. They're not shortcuts. They're not summaries of the math to get the kid to the answer fast. Algorithms absolutely have a place in my work. They come after the reasoning, the estimating, the explaining. That way, the algorithm becomes a tool that students understand and can use, not just a procedure that they follow because that's what we do in math. When students reach the point of understanding, the algorithms make sense quickly and they stick. If this way of thinking resonates with you, then Word Problem Workshop goes so much deeper into task design, teacher facilitation, how to respond to student thinking in the moment, how to facilitate that community discussion that we want our students having.